In this presentations, we are going to discuss about the runtime storage environment and code generations with the subtopic is basic block and flow graphs. So in this basic blocks, our first jobs is first partitions the sequence of 3 address code into the instructions into the basic blocks. We begin the new basic blocks with the first instructions and keep adding the instructions until we meet entire jump, a conditional jump or label in the following instructions. So the absence of a jumps and the labels control process sequence from one instructions to the next. So this idea is formalized in the following algorithm. So where the input is in sequence of 3 address code, then the output is basic blocks. So now we are going to discuss about how to generate a basic blocks. Okay, so here the method is, and first we determine those instructions in the intermediate code that are a leader. So that is the first instructions in some basic block. So the instruction just passes the end of the intermediate program is not included as a leader. The rules for finding the leader is the first 3 address instructions in the intermediate code is in leader. Then the target, the instructions that is a target of the conditional and unconditional jump is in leader, and that instruction that is followed the conditional and unconditional instructions is in leader. So this 3 kind of procedures is followed for the leader usage. The next use informations. So knowing when the values of the variables will be used next in essentially for the generating of good code. So if the value of a variable that is currently in a registers will never be referenced subsequently, then that registers can be assigned to another variables. If that variables does not used for the future's purpose, so that variable registers to be replaced and used by any other values. So that kind of informations reduce the memory usage and executes the informations efficiently, improve the runtime also. So if the algorithm where how to find the next use informations. So before that we know the liveness of the variables. So here how to find the liveness and the next use of the informations by the algorithm. So here the input is the basic block B of a 3 address statements. We assume that the simple table initially showed all non-temporary variables in the B as being live on exit, and the output is at each statements x is equal to y plus z in B. We attached to I the liveness and the next is informations of x, y, z. That means here consider the ith instruction is in x is equal to y plus z. Okay, in the basic block B. Okay, so here how to maintain the liveness and then next use informations. So first we start at least the statements in the B and scan backwards to the beginnings of the B. At each statement psi x is equal to y plus z in B. So we do the following: attach the statements by the informations currently found in the symbol table recording the next use and liveness of x, y and z. In the symbol table set x is to not live and no next use. In the symbol table set y and 2 and z, okay, y and z to live and the next use of the y and z to I. It may be used for the next use is an I. Here we have used plus as a simple representations, any operator. So if 3 address statements is the form of x is equal to plus y or x is equal to y, the steps are the same as above. So in this flow graph, the data flow of the basic block is described by the flow graph. Once an intermediate code program is partitioned into basics blocks, we represents the flow of control between the block is described. So the nodes of the flow graph are the basic blocks here, because the flow graph describes the data flow between the basic blocks. Okay, so there is an edge from a block B to C if and only if it is a possible for the first instructions in the block C to immediately follow the last instructions in the block B. So there are two ways that such a edge could be justified. So there's a conditional or unconditional jump from the end of the B to the beginning of C. So C immediately follows B in the original order. Normally the sequence of 3 address code is separated. So in that time this block of B has ended with one instructions, then that execution start with the first instructions of the C. So in that time doesn't worry about the conditional and unconditional instructions. So in that we add two nodes called a entry and exit that do not corresponding to executable intermediate instructions. There is an edge from entry to the first executable node of the own graph. So that is two basic blocks that comes from the first instructions of the intermediate codes. So in this descriptions, actually the first entry, then block B1, B2, B3, B4, B5. So here the executions, after the executions of the block 3 as a control back to the same block 3. So it has a self loop. But in the B4 has a jump instructions that may be conditional. This is a conditional instructions. So it is moved to the block B2. So this is a actual executions of the sequence of blocks. So the representations of flow graphs, it's a being quite ordinary graph. So can be represented by any of the data structures appropriate for the graphs. The content of the nodes needs either own representations. So normal graph representations is in flow graph representations. So we might represent the content of the nodes by the pointers to the leaders in the array of the 3 address statements together with the account of the number of instructions and the second pointer to the last instructions. So in this loops, so the loops is used for executes the particular sequence of instructions based on the conditions. So in this programming language, constructs like while statements, do while statements and for statements naturally gives rise in the loops in the programs. So while statements until satisfied the conditions, it moved to the instructions, to the executions. Thank you.